Hey guys, welcome 6.5 video. Here we go. Let's go ahead and get started. 6.5, all we are doing is we're determining whether a parallelogram is a rhombus rectangle based on the properties of its diagonals. We're also going to be looking at squares as well. So we're basically saying, how can I identify what is a parallelogram? So let's go ahead and take a look. Can you see the tree? It's really hard to do this. There, I'm pointing to the star. Okay. Alright, so our first theorem, we have three theorems here that help us out. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So we're basically using our properties that we know, and we're doing kind of the converse. So we originally said if a rhombus, then we know that the diagonals are going to be perpendicular. Now we're saying if the diagonals are perpendicular, then it's a rhombus. So we can kind of go ahead and conclude that we can get that if we had perpendicular diagonals. Another way we can go ahead and prove it's a rhombus is if one of the diagonals bisects a pair of opposite angles. So 3 and 4 are congruent, 1 and 2 are congruent, then we know we're talking about a rhombus. And last but not least, this one is for a rectangle. If the diagonals of a parallelogram are congruent, then we know we're talking about a rectangle. So again, we already know these properties, we're just now applying them in kind of the converse method by flipping it around and saying, hey, if this is true, then we know we have this shape versus saying, here's the shape, what do you know is true? Okay. So let's go ahead and take a look at our first problem. Again, we're just identifying special parallelograms. And our first parallelogram is here. Can you conclude the parallelogram is a rhombus, square, or a rectangle? Well, we actually can conclude something. You see here the diagonal right here is bisecting opposite angles. So this answer is very short and quick. It's a rhombus. Okay, just you have to know our properties well. And if you know your properties well, this becomes very simple. If you don't know them very well, it becomes difficult. So that one's as simple as that's a rhombus because our theorem states if opposite angles bisect from the diagonal, then we know it's a rhombus. Let's go ahead and do another example. Here we have a parallelogram with angle measures 20, 160, 20, and 160. So let's go ahead and draw a parallelogram. That was beautiful looking. Now we know it's a parallelogram, so these have to be opposite from one another. 160, 160, 160. Here we see opposite angles are congruent. They consecutive angles add to 180. We know we have parallel sides. Can we conclude it's a rhombus? I don't know anything about the sides to say, and I don't know if the diagonals are bisecting, so I can't say that. Is it a rectangle? Well, I know for sure it's not a rectangle because these are not 90 degrees, and I know it's not a square. So the answer is, can you conclude it's a rhombus? It could be a rhombus. So our answer would be, it could be, we don't know for sure, but it could be a rhombus. Remember, whenever you're doing any problem, you have to write the whole problem out. Otherwise, it doesn't really help you to go back and do it. But this could be a rhombus because we don't know about the sides. All right. Let's go ahead and take a look at our next example. This video is kind of a short one, quick one, kind of going over a lot of this similar stuff. For what value of x is ABCD a rhombus? So if this is where a rhombus, these two would have to be congruent. So essentially we're going to take 6x minus 2 and we're going to set it equal to 4x plus 8. Okay, so if these were set equal to each other, we know it's a rhombus. That means this diagonal bisected this. These two guys are congruent. So go ahead and solve. We subtract 4x from both sides. We get 2x minus 2 equals 8. Go ahead and add the 2 over. 2x equals 10. And then we get x equals 5. So for what value of x, we should get x equals 5. That would make sure that we have a rhombus. Okie dokie. Last question. I know this one's a very quick video. Again, because we kind of already talked about a lot of this stuff. We're just doing the converse of it, which makes it nice. What value of y would DEFG be a rectangle? Well, we know that this diagonal here, this whole diagonal here, has to be equal to this whole diagonal here. And if that were true, then we would have a rectangle. And since a parallelogram bisects, the diagonals bisect each other, we actually know that this segment, this segment, this segment, and this segment are all congruent. So again, kind of like the other problem, we just have to go ahead and set these equal to each other. Notice, most of geometry, our math, simple. It's the vocab, our theorems that help dictate and drive how we're going to create the equation. So here we go. Let's see, subtract 5y from both sides. That's a good looking 5. We get 3 equals 2y minus 5. Ooh, that was an ugly looking y. Add the 5 over, we get 8 equals 2y. Y is going to equal 4. Having not great luck with the y's. Anyways, alright, well, good job everybody, and we'll see you.